Hey, welcome to another lesson in our IT series on the Practical Assessment Task, or PAT. As you know, the PAT is divided into 3 phases to make it easier for you. Phase 1 deals with the proposal document. So far, we have dealt with the problem statement, research and analysis of the problem. Today, we will identify the input, output, processing and storage requirements, and propose a solution to the problem. Then we will move on to phase 2, design the solution. In the previous lesson, we investigated and analyzed the client's needs. We also put together a problem statement, explaining the problems the client was experiencing that could be solved by developing custom-made software. Today, we will identify the essential requirements of the software and suggest a possible solution. At the end of this lesson, you should be able to identify requirements for user input from mouse or keyboard, processing like calculations, comparisons, searching and sorting, storage in file on the hard drive, output by the program to the monitor, and describe a possible solution. As always, it's important to keep a record of everything you do, as you will need to submit your notes with your possible solution. Here he is. Good morning.
Good morning, Mr. Kumar.
What's so urgent that you're willing to give up your break?
The pet is giving me sleepless nights.
What's the problem?
Well, I've identified a client, you, the teacher. After I chatted to you, I figured out that you need something to make it easier to teach IT.
Anything specific that you identified?
Yes. You want us to teach and test IT terms and definitions with multiple choice and match the column test. So I've put together a problem statement, investigated, and decided to go for a teach and test kind of game.
Sounds good so far.
Can I start programming?
Not so fast, Tabo. Now that you know what your client's needs are, you have to figure out what the requirements of your software are. This is done by referring to the information you gathered in the investigation. Use the notes you made and, if necessary, talk to the client and end user again. Then write down exactly what the requirements are for your input, processing, storage, and output. It's important to discuss all the requirements in detail in your proposed solution document for 2 reasons. To make sure you know exactly what you have to do in your PAT, and to show your client what you have in mind. That way, you can make changes early on.
Where do I start?
Pretend you are using the program. What will you, the end user, see and be asked to do when you first access the software?
You mean like a main page where you enter the site?
Yeah. Let's look at an early example. This software takes you through phase 3 of the PAT.
Nice.
Here's an example of where a user is asked to register.
Cool layout.
This program requires login. Once the user has registered and logged on, they'll decide which game to play and at which level. That means you're testing the users and would have to give them a score.
You'll also have to give them a chance to improve their score every time they use the software. And to do that, you have to keep record of the learner's previous scores.
In other words, you'd have to store data. And how would you differentiate between the different learners?
Username and password to log on.
So the main page would have to be a logon screen with an option for the first-time user to register. That would take users where they can input all their personal details and get a username.
And after they log on, they can select what they want to do.
See, if you know what kind of software you want to develop, it's easy to determine what the requirements are. Let's take a closer look at the requirements you have identified for your PAT. You say you'd like your users to log on, right? When they type a username and password, what are they providing? Input or output?
Input. 'Input' 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 ' Aren't they also giving input by clicking buttons when they finish typing?
Correct. What happens to the password input?
It gets processed.
And then? Do they reuse their password?
Of course. Oh, that's it. The program has to remember it, so the data will have to be stored.
That's right. The username and password are input and stored when the user registers. When the user logs on, the new input is processed by comparing the attempted password with the stored password. If they match, that takes you to the next step.
The game screen.
So once the user provides input, it is stored and processed. But what happens next?
That triggers output, the results. In this case, it could be a message saying password was correct or incorrect.
Exactly. Even the opening screen they see before they give the input is output. It's actually quite logical. Let's look more closely at the different requirements. Input is any information given by typing, performing an action like selecting an option, or indicating a process must start or stop. Let's look at a practical example. Remember Silingua, the educational freeway we referred to before? When you access it, this is what you see. The site welcomes you and asks for input right away. In this case, they don't want a password. The input required is selecting your home language. Once you have done this, you indicate the process must continue by moving your mouse, placing your cursor over OK, and clicking. The data the user provides is then stored temporarily and is used in processing to select the correct language to teach. Storage is the term we use for where we keep the data when moving data from one place to another. Temporary storage will use the RAM, and permanent storage will use the hard drive. Processing involves calculations, logical comparisons with the result of true or false, and moving data to a storage location. And the last requirement is output.
That's everything the program provides the user with. The logon screen, welcome message, game option, your score, your game history.
You're getting the hang of this. Here's an example. You're given a choice of 4 possible answers to a question. You provide input by exercising a choice and performing an action using your mouse. The input is stored and processed and you get output. Correct answer. Output is given in GUI components. In phase 1, you only have to state what will be seen by the user. You don't have to state what kind of output component you will use.
What if the output is a sound? Like if you click on a word to hear the correct pronunciation?
You'd simply state, the user will hear the term pronounced correctly. Once you've identified all the requirements of your program, you will have to add it to the proposal document you started putting together from the start of phase 1.
Should I list the requirements in bullet form?
Most learners try to list the requirements by stating all the input first, and then stating all the processing and so on. Like in this example. The learner looked at the input and found it could include the user and administrator's details and passwords, game and level selection. The learner then covered processing and said it could involve checking the password, calculating scores and so on. Lastly, the learner listed the output requirements as the score and gaming history. The problem with doing it this way is that you then tend to think item by item. You are trying to think what should happen, but not in any context. A list like this won't give the client a good idea of what the program will be able to do. It is better to focus on your specific program. Rather ask yourself what your program will do at each stage. Once you've figured this out, divide your program into different stages like register, login, game, and so on. Then list the requirements for each stage.
So you take one screen at a time, and you list all the requirements for that screen on one page.
Yes. Even if you're not exactly sure how the game will work, or how the database will be structured or manipulated, make general suggestions. A logon screen, welcome message, game choices, and so on. Let me show you how I go about it. Say the user opens the program and is shown a logon screen with different options. Register, log on, change password. If the user chooses to register, what would be expected of her?
Input, username and password.
And what would this password be?
Processed, maybe by checking that nobody else has already taken the username and that the password is long enough, then stored in a database. A welcome message would pop up, I suppose.
Yeah. The username and password is?
Input.
It is processed and stored.
And you get output.
We can do the same with the logon option. What would that entail, Thabo?
It'll ask for my username and password. Check my password if they're correct. It'll store my username in RAM so it can be used during the game. Then I can choose a game.
Good. Can you identify the input and the output?
The username and password is input. Checking the password is processing. If the user logs on successfully, the username is temporarily stored for giving personalized messages. Choosing a game is input. The game screen is output, and that will have its own list of input, processing, and output.
Very good. Now you're ready to add this to your proposal document. A useful way to make a clear statement is to start your sentences with the user will for input, the user will be shown for output, and the program will for processing and storage. Let's look at the example we worked on. The user will open the program and be shown the logon screen, which offers the options. 1. Register. Here, the user will input their details and password, which will be stored in the database. A welcome message will be shown. Log on. The user's username and password will be input and checked against the stored details. If logon succeeds, details about the user will be stored in a user type object in RAM to be used throughout the session time from log on to log off. Change password. The user will first have to log on. Then the new password will be typed in and stored in the database. We are now ready to describe a possible solution to the problem. When you do this for your PAT, keep in mind that your PAT has to include certain things. A database with multiple tables. One or more text files. Objects and classes. The possible solution is presented in this way. A summary of the requirements written as 1 or 2 paragraphs, showing scope of the program, showing limitations of the program. Remember, the scope of the program refers to what it can do. Limitation refers to what it can't do. Let's see if you've been paying attention. The client is a history teacher. He wants a program to teach learners about the art produced during the Italian Renaissance. You need to state a possible solution, which will give a clear idea about what your program will and won't be able to do. Any ideas?
I would create a database that stores an image of each of the artworks. The name of the artist, the date it was created, the type of art it is, and a description.
What about the interface? The screen?
It'll work like an art gallery. The user will select a work of art and will see all the information about it. When the user has walked through the gallery, he will have to take a test on what he has seen.
That's great. Now let's check if the solution gives the history teacher a good idea about the program you intend to create. Tabo's solution explains exactly what data will be stored and how it will be presented. He also told us what the screen, the GUI, will be like, even though we can't actually see the screen. I'd say that Tabo's solution has a broad scope. What additions could you add in the future?
Maybe more info on the lives of the artists, or a map of what Italy was like during the Renaissance that shows you where the work of art was created.
Yes. And what are the limitations of the program?
Oh, that's a good point. I might struggle to get some of the images. It might also be difficult to get permission to use the image because of the copyright.
Now you're ready to compile a possible solution to your client's need and add it to your proposal document. Make sure to cover the requirements for input, processing, storage, and output, as well as the possible solution. Remember that the proposal document we refer to in phase 1 is a proposal you present to the client. You're trying to sell the program to the client. The client will either give you a contract and pay you or say no thanks, based on this proposal. So always attach all the research you used in the investigation. Also attach a list of all the references. This way, the client and the teacher can check references and make sure you did what you claim to have done. The Netball Coach wants a program that will help users to record all the games in the netball season. Check that all the rules have been followed and calculate the results of each game. Write a solution for her, showing all the requirements for input, processing, storage, and output. That's all for today. Be sure to complete phase 1 before you carry on with phase 2.